is. So, like, what exactly is GDG? GDG is Google Developer Group. It's basically focused on developers and like the community around them. And we basically are involved in doing demos, tech talks, code snippets, and like hackathons. You can obviously do like other things around the tech community, but our main focus is towards all of these stuff. Okay, we are open for everyone, and this we get this question a lot of time. We are not run by any corporation. Google supports us, but we are not hired by Google to do this. It's a voluntary contribution towards the developer community. Okay, so how is it different from other meetups? Well, we would be doing regular monthly meetups, which is pretty common for other meetups too. But we stand out by doing meetups specific to technologies that are developed by Google. So that can be like you have machine learning technology, TensorFlow, you have Kubernetes, the one that we'll be talking about. You have Android and all the other stuff. Our sessions are basically technical and hands-on, and like it's community shaped. We say this because we take your feedback. We listen to what you want, and we'll do the next meetup for that. It's not gonna be something that like we just decided and we'll do the meetup. We want you to speak up, come up and tell us like we want this type of talk, we want this type of session, we want to learn this type of technology, and we'll try and get you like special engineers or like Google developer experts to handle those type of sessions and provide you the required knowledge. So GDG Cloud Vancouver. So our name is a bit like long, I know that, but it's specifically focused towards cloud technologies, but we also are inclined towards open source stuff. So like you have your gRPC, you have Kubernetes, you have TensorFlow. If you have any other topic that you can think of that is related to open source or Google, we'll be supporting that. Okay. We have experts from Google platform who come up to our sessions, who will be taking your sessions, and they will be explaining you the specific technologies. We have like demo solutions, code labs, hackathons, the common thing. And we also have community evangelists, like the developer advocates that you have. Plus, we would be making sure that you get access to Googlers. Okay, so we have our contacts. We'll be getting more Googlers to come up and like take more sessions for you. I said it. We are more community shaped, and for this we need your help. We want you to come up and like open up issues for the talks. You can open up. So when I say issues, we are basically available on GitHub, where we have a special repository that's titled as talks, where you can go and open up issue. People can vote up there by like giving thumbs up on the issue, and we'll know that okay, this is a particular topic everyone is interested in. Okay, so you can do that. We have a specific repository that is for resources. If you want a particular type of project, or you are having some like specific requirement for a different type of session, we will provide you the resources for it through that. Since you are at this meetup, take as many pictures as you can. Do a lot of like tweeting around social media, put posts, like just have a good time. Okay. One more thing. If you want to speak at our events, you will have to let us know. Like me and Vikram, we are both the organizers of this meetup, and you can just contact us on our meetup page, and we'll make sure that you get the podium to like speak up and like share your knowledge if you have enough. Okay. This is an announcement. So we are having DevFest. It is a single-day event where we'll be having speakers from Googlers and community members. And this event is happening on October 14th at Hootsuite. You can see the site. The link is there. If you want, you can take a picture. If you want, tweet it. We'll be having hands-on sessions. We probably would be having 2 tracks, which will be covering different Google technologies. We'll share the slide too, so you don't have to like worry about the link. The website actually is available. Let me see if I can show you that. Hopefully I haven't closed this. So this is our website right now. We are still updating this like in terms of more information, but most of the schedule and topics that would be available would get up here. Okay. Let's get back to slides. Yep. future events. So the ones that you're seeing on this side, they are they are the planned ones. You can see all of those listed on our meetup, but we will be having more. And all of these are happening like within, I think, 2 months time that you're seeing right now. Like by September, October, and you'll have all of these events done. We'll be having like data lab with dogs and devs. This is a good one. DevFest is obviously a full day event. That's a really nice one. We'll be having Google Developer Days extended. This is happening in Europe, but we'll be having extended version in Vancouver. And if you guys have a suggestion for us having more meetups like for different technology related to cloud, we'll be like happy to have that type of meetup here. Okay. And after this, I think we'll begin. Let me call up on stage Vikram, who will be taking your next session. Vikram. Woo. Yep. Yes. Somebody can announce that. I don't remember that.
All right, so the guest Wi-Fi is Slack guest, and the password is Slack4U2 with a capital S, a capital U, and exclamation point after the 2. And the 2 is a number, yes. The 4 and 2 are both numbers. I could just read the whole thing out if that, if that would make it easier. Or we can put a slide up for a second.
Nice. Awesome. I'll let everybody set up, sign in, tweet about us. Are we ready? Yep, nice. All right. So, nice. Just basic headline. We are doing this Kubernetes meetup, which is a meetup based upon Kubernetes 101. We will talk about how do you set up Kubernetes, why do you need Kubernetes, how it works, and everything else. We are GDG Cloud Vancouver, Google Developers Group, Cloud Vancouver. The hashtag is GDGCV. This event was planned with Kubernetes birthday, which was on June or July, now I'm forgetting, July 21st. And based upon that, this is Kubernetes birthday. So if you are posting anything on social media, try to use K8S birthday tag. My name is Vikram Tiwari. I am Google Developer Expert for Google Cloud Platform. And I'll be today walking you through Kubernetes and how to use that, or why would you use that. So what's in this for you? Why should you listen to me? Important stuff. So I don't know how many of you are application developers, or you are scaling some applications, or you are in the backend, or you are database people. I don't know. Admins have been removed totally from the configuration these days. So no matter which role you are at, you have always faced this problem at your company, which is called scaling. And whenever it comes to that, everyone asks you, are you building this in a scalable manner? Is this really scalable? Can we scale this to n number of users? Or other part comes up, resilience. How resilient is this what you are building? Can this survive this massive load? Can this take n number of errors and still be up? So all of those problems are in every aspect of computer science. I hope most of us here are from computer science domain. And Kubernetes is one of the tools that helps solve that to one extent, not 100%, but because there are so many problems. But whenever you deploy anything on servers, Kubernetes will be there to help you. So hopefully everyone is set up. Yes. All right, we'll go ahead. So how is an app, or what was an app up till now? So not up till now, but like it's been some time since this has changed. But normally what an app is you have one whole app, that is your app that we are referencing here as a monolith. And Nginx is something that is living as a proxy in front of that. And what happens is like you put this all into a machine, and that machine interacts with Nginx, which interacts with your monolithic app. So this was up till now like how people use to deploy, or this is like, even right now, people do that a lot, which I think people should not. The new architecture is microservices architecture, which is you have for each individual work that you want to do, you build a service for that. And all of those microservices talk to each other. And once there is a load balancer in front of that or a proxy in front of that, which configures where the services are going. Right? So with Kubernetes, the best thing is that no matter if you are a monolith app or you are a microservices-based app, you can run both of them and make use of Kubernetes and its features for both of these types of app. So if you are kind of right now stuck with a legacy app, which is a monolith, you don't have to worry about working and coding all of that to port that into a microservice, and only then you can use Kubernetes. You can still use that as it is right now. So what Kubernetes is basically a different way of thought process that you use to deploy your apps to make sure that they are scalable and resilient. So just a different way of packaging and distributing your app. So dependency metrics. So this is the core problem, the reason that Kubernetes-like stuff are there. But this problem is solved by Docker. We will talk about that in a minute. So what happens normally in a coding scenario? That you have some services that you want, like your operating system front end. These are the variables that will happen. And then there are n number of people or n number of systems where your application has to go. So if you talk about what is happening, this is the landscape. There will be one developer who is on OS X and one who is on Windows, and you want to have same application run on both of them, and it won't run. But when you finally at least solve that, like runs on my machine, that's the problem. You solve that, you have to now pass it to QA, where you don't need a lot of service reliability, but as soon as it goes to staging, you need that reliability there, and you need to change the database because it should access production database. And as soon as it goes, staging database, as soon as it goes to production, you not only need all of those, you also need logs. Logs are really important in order to understand what is happening with your application. So all of these requirements for a successful application change as they go from one laptop or one deployment process to another. And this is a huge problem because what you cannot do is spend 15 minutes of your time every time it has to go to a new machine. You cannot spend 15 minutes, 20 minutes, which ends up taking a long time because you have to Google something and something Stack Overflow is not working. So you cannot take that much time to spawn up your application every time that you have to put it on a new kind of machine or new kind of server or a new kind of configuration. So for that, the solution that was proposed, or this has been a solution since a long time, is what you do is you create virtual machines. And in a virtual machine, you can put your OS, you can put your application, and it can live inside a big server. That works, that there's no issue with that. But that is saying that I wanted a laptop to carry, and I'm carrying this. So you wanted something really small that you can carry around and easily move, but rather than doing that, you're carrying a whole big thing. I don't know. All right, so solution to that comes containers. So containers are basically saying that we will, rather than getting those big virtual machines, we will give you a small unit that you can deploy and run multiple times and multiple places. So for containers, the easiest way to run a container is Docker. You use Docker to create an image, and then to create an image, all you need is a basic configuration file, which is Docker file, and you use that to create a Docker image. You use that image. Image is basically saying that this is a copy that I want, and you can run it now on any type of hardware or software platform. So dependency metrics, that was distributed, everything was different, now everything is same. No matter where you are deploying, no matter what the machine is, no matter what the configuration platform is, you have everything same everywhere. So the problem is solved. This one problem, which was how do I take my code from one platform to other platforms? So that is done. Next, but that is just one machine. As in, here you deployed it on dev1 laptop. It is not talking to dev2 laptop right now in case your application needs to scale up. So what it is doing is it is a single application on a single machine. What if you end up deploying your production server to one single machine and that machine catches fire? Hopefully not. But if that machine catches fire, your application is gone down. So how do you use a Docker image to a container? Now, how do you use this container to make sure that your service is reliable, is there when people need it? So what you do is, as you add more machines, there are more things that come up. There's health problem, there's a discovery problem, where is your application running? There's a scheduling problem, when does the application needs to go up, come down? There's a monitoring problem, like you have now 5 different applications and logs are coming at the same moment of time from all 5 of them. You don't know whether this log is coming from this machine or that machine, and how do you troubleshoot that? Configuration, security, scaling, of course. So solution to that is Kubernetes. So after you have created a way of, after you have created a copy of your code, which is in the Docker image form, now you can use that to deploy it anywhere. And that is the point that Kubernetes comes in. So it is an open source software, open API container orchestration engine. So with open API means that whatever Kubernetes is doing is available to you as an API. You can listen to that, you can make those events happen from outside. So we will talk about that example later on. But what that means is, as a software developer, that this whole project is open source. You can contribute to this. You can extend this software to your own needs. If you are a bank, banks generally don't rely upon external softwares or open source. You can clone this internally, add your services on top of it, add your security layers on top of this, and run it internally. Don't have to worry about anything. It supports multiple clouds. This is one of the buzzwords, I would say, that everyone is doing these days, but nobody is actually implementing it. Is what you want is, if S3 goes down, you are still up. You want that. And for that, you need to be on multiple clouds. Yeah, it needs to be there. Plus, the biggest thing with this is like this this project is based upon Google's learning. So Google had this project internally. Now I'm forgetting the name, but they had Borg. Yes. So Borg was the name of the project which was internally, and they made it open source. So Google has been running servers in production at a scalable manner since forever. I don't remember last time when I typed google.com and it never loaded up. So they know how to do this, and they have put up all of that engineering research into this. And so what you get is the way of doing things Google way, which is not necessarily the perfect way, but at least it's the scalable way and resilient. All right, so let's talk about the concepts of this. So whenever you are taking a new program or new software, you need to understand the core concepts in there. So Kubernetes, the biggest feature that is causing Kubernetes to be one of the highest contributed program, or like contributed open source software, plus most used program in like diverse kind of industry, is it is focused more upon simplicity than complexity. It tries to make everything more simple. That's the core abstraction behind everything, every new feature that is coming up. All right, the control loops, cattle pit, we'll talk about that. So the biggest thing that you have to think differently about. So whenever you are thinking about an application, the way we started, is this is my application. You are talking about one specific instance of that. What Kubernetes says, don't think about that way. Think of it as a cattle way. So this is your application, this is your pet. You care about this application, whether this goes down, whether this is writing logs or not. You care about all of this that happens with this application. So that is a pet. You want to do it cattle way. So what you do is, a pet has like a name, it is unique or rare, it requires personal attention. This is the way that normally applications are deployed. What Kubernetes says, just think about it a bit different way. You think about cattle. You need this many applications up. You need something up. It runs as a group. If it dies, you make hamburgers. So desired state. So this is like, that is the core concept about how you start thinking about it. Once you have your mindset in that frame, that no, there's no one application. There's a desired state. All I care about is my application should be up. I should be able to access it. So you set up a desired state. Your desired state is, let's say, I need 3 front-end servers, 2 services, and 1 back-end server. Okay, this is all you need to do for Kubernetes to get started. So first, you create your Docker images. Then you tell that I need 3 front-end servers, 2 services server, and 1 backend. And that's all as a user you have to do. Same way of saying that. So another way of thinking this is employees, not children. So when you are when you have a child, I don't, but somebody wrote this really good way of doing that, that you have to tell a child, if you want to tell him to go to sleep, you have to tell him each and every step. So when you're deploying your app, you have to do each and every step. Rather than that, what Kubernetes gives you is just say, deploy it, and that's it. The same thing that you have to tell an employee rather than a kid. So, and really good story behind this was like, if you don't tell your kid to go upstairs, you end up with a naked kid in your bedroom, in your master bedroom or whatever. Yeah. Pods. So pods is a logical unit in Kubernetes, a logical application unit. It can contain one or more container. So let's say you had 3 services we talked about right now. One is front end, one is services, 3 images, one is front end, one is services, one is back end. So a pod can hold multiple containers. So you could have all 3 of them as a container living in one single pod, or you can have it across the pods. A pod shares namespace, and for every pod, there's one IP. So what Kubernetes gives you is, as soon as you ask for a pod, you don't have to worry about creating an IP for that pod, creating the namespaces for that pod. All of that is being done by Kubernetes for you. Now, health checks. So think of pod as like this one machine inside which you are putting these multiple containers for now. Then we come to monitoring and health checks. So first thing was where you deploy your app. So you have deployed your app now in a pod. We will come to that in a minute, but there your application is right now. Now, how do you actually make sure that application is up or down, or health checks, or you monitor that? For that, Kubernetes has a really, really good monitoring and health checks. I wrote a blog post about it, and like this is like the biggest differentiator according to me for Kubernetes. What you think of is you always assume that your service is down. So if you always assume that your service is down, then what you are always trying to do is make it go up. So what Kubernetes does is it checks, are you alive? Application says, nope, I'm not alive. All right, I'm going to restart you. It restarts that app, now application is alive. But even at that point, it's not finished, because what it is assuming is application is down. So it again has to ask, are you up? So application is starting up, application started up. Are you alive? It again checks, are you alive? And it will keep doing that until like it fails. And as soon as it fails, it will restart and give it back up again. So you don't have to personally go and like refresh your website every few minutes to make sure that it is up. Kubernetes will do it for you. All your services are up. Next biggest thing that is a concern with all of the development efforts that we have is around secrets. So whenever you build an app, you connect with an API, and now you need a secret. You need to store that API token somewhere, but you cannot embed it in your app, because like, let's say if your application code gets not infected, but like shared with somebody else, and now your secret is available to somebody else. So for that, Kubernetes has secrets. What you do is you create a Kubernetes secret by running one simple command. Like you put your secrets in a file and assign that as a secret value. This example is basically saying your TLS certificates, those are required for HTTPS. They use that to create a secret for you. So you use that, you say create a pod for this, it creates a pod, it adds your secret to that, it adds the file system to that machine, that pod, assigns it an IP, and creates a load balancer for it. And all of this is done for you by Kubernetes by just saying that you need a pod, and you have created a secret for that. You say that I want that secret attached to that pod, and it will do all of that for you. So what you are not doing is going up and like starting a new machine, installing all the operating system, adding your virtual machine, that new secrets pod to this, and all of that is gone for you. Services. Another concept in that is when you are looking at anything in Kubernetes, now you have pods, is go one level higher. Why do you have to worry about pods? All you have to worry about is whether your service is up or not. So don't worry about pod. What you say is, I need 3 services up at any point in time. So it's a persistent endpoint for pod. We'll come to that. All right. So you say at a level that you say that I need 3 services or 3 instances of this service up at the time. What you can do is you can give them labels. As you give them labels, that way you can differentiate between one version of your service to another. Here we have a version 1, both are version 1, but they are running on track stable and track test. So when you are talking about, I want my version 1 application to be up, it will check for this whole thing. When you say, I want my track stable only, it will check for this. So what this gives you is, rather than you having to remember where is your stable application running and where is your next deployment is running, you don't have to worry about that. You just put labels on everything and use those labels to get back to your application. Kubernetes manage where is your label right now, on which machine. You don't have to hunt down where it is. So yeah, labels, you can use labels for IPs and like pods selection. Deployments, we go one level higher up even. What you don't care about is how are those services distributed across machines. So let's say you got 3 machines right now, and now you want your applications to be up and utilize all 3 of those machines, and you want your services to be up. So what you say is, I want 1 replica. Kubernetes will decide where it should host that replica. You said you want 3 replica. At some point in time, you say, I want 3 of those now. What Kubernetes will say, okay, let's check. How many do we have? It says there's a single one. We need 2 more. It will spawn up 2 more for you. All you have to do is say, I need more, or I need less. It will also do it less for you. Like it will delete something for you. So here, let's say this machine went down. Something happened on that machine. Kubernetes will see, okay, we needed 3 replicas. That's what users asked me to do. And what I'm doing as a Kubernetes is like, I'm checking every time whether what user has asked, has it been fulfilled? So it will check, okay, user asked for 3, there are only 2. Let's spawn a new one. Since node 3 is not available, let's spawn it somewhere else where it can run. So it will automatically make sure that your application is running where it can run. Rolling updates. This is like once you have all of the stuff sorted out, then your developer comes up, all right, we have a new version now. Do I have to do this whole thing again for a new version? And I don't know about other companies, but at least in our company, we do updates every few minutes, every few hours. If we cannot do that, there's at least 1 update going on into production every day. So that means that no, you cannot set up every day some time aside just to make deployments. What you need at that point is rolling updates. So let's say this is your application right now. It's running version 1 on all 3 of those nodes. As soon as you need version 2, what you do is you tell Kubernetes, this is my new version. Roll it up to version 2. Kubernetes will put it into a node, spawn the pod up, connect it to the service. At this point, your traffic is going to 3 version 1 services and 1 version 2 service. So your traffic is distributed. At this point, you can test. Like, let's say this is 25% of your traffic right now. So you can test whether your application is working fine or not. You can do A/B testing with that. You can just leave it like that and like ask Kubernetes not to do the complete roll up. You can also roll back at this point. If you see that your application is not working fine, you can say, no, I just want to go back to version 1, and Kubernetes will take you back to 1. But let's say you are fine with that, your application is working fine. What does Kubernetes do next? It will remove the connection from that. So first, it will make sure that there is no connection, there is no traffic going to that, and only then it will remove that instance. So it's not like it was serving some client's request and it just gone from the space. It will be there until all the traffic stops. Then it will delete that. Then it will spawn a new one. Again, the same process. Connect it to those, give it traffic, remove traffic from the older one, delete it. Add a new one, get traffic, remove the older traffic, remove that. Now your version 2 is up. There are more ways of doing that. You can add your own if you want, since the API is openly available. If you think that your process or your way of doing something is better, you can write your own spec around this, and it will work that way only. So recap. Wow, we are running good. All right. So Kubernetes is just a quick recap. Manage applications, not machines. What you want as a developer, you have to think about your application. You should not be thinking about a machine or where you have to run it. Just think about your application. How many do you want? How much do you want it to be up? What is the resilience? All of that. Don't have to worry about the machine where it is running. Multiple cloud, bare metal. You can run applications on Google as well as Azure, as well as S3, all of AWS, and all of them can talk to each other. Don't have to worry about saying that I am now limited only to Google because Kubernetes is by Google. It's an open source project. Everyone can use it, and like on any platform. You can run it on your own machine and at the same time run some applications from like Google's container services. Container is a subatomic unit in Kubernetes. It's where you are putting your application, where your application is actually running. Pods are logical units where you can have multiple containers. We are going bottom up. For every pod, you can do monitoring and health check. You will see whether it is running or not. You have secrets to make sure that your configurations are secure, all your secrets are fine. You have services and high abstraction level where you don't have to worry about what is running, you just care about a service being up or not. Then you have labels of easily identifying what is a service or how do you connect to a service or making calls to that or identifying which is what. You don't have to worry about which machine it is on. You have to just worry about what label did you give it to it. That's it. Deployments, even high level abstraction, all you care about is this should be up. That's it. And you said like I want 3 versions and it makes sure that it is up. Rolling updates, that was the final thing. You push a new update, it will roll it up for you one by one. What's more, there are persistent disk if you want. So let's say one of your machine goes down, the disk with that also goes down. So what you can do is you can add persistent disk if you're running a database kind of server. So databases need that data to be persistent. You don't want that to lose that data as the application is rolling up or rolling down. You need logging and monitoring. You need web UI to look all of that. There's cluster federation, there's ingress, lots of concepts in there. There's also a course on this, which is called Scalable Microservices with Kubernetes. It's on Udacity. These slides will be made public, so don't worry about that. You can come to this link and see that. Finally, thank you, and we will transition now to an actual hands-on code lab session. All right. All right, so this event is on Slack, so we are gonna build a Slack bot with Node.js and run it on Kubernetes. So if you are not aware, this is Code Labs. Code Labs is, Google has created these small code sections where you can come in and learn about a new technology using some example. So what you do is you start with a very basic overview. You will start here, and at the end, you will have an application up and running, and you can remove that as well totally. This is all like actual material. You will need a login on GCP or at least whatever technology you are trying to test it. Let me just show that. Like there are code labs on almost all the technologies here that Google has at least. So category, if you go down, there's ads, analytics, Android, apps, assistant, cast, cloud, Firebase, IoT, TensorFlow, everything. So all the types, all the things that you want to learn, you can just go here and look for it. And you will find that, and you can just run through that. So today we are going to try a cloud Slack bot code lab. All right. So what we are going to do is we'll build a Node.js based Slack bot and deploy it on Kubernetes. All right. Let's see how I'm going to do that with this mic. All right. So first of all, I hope all of you are aware about Slack, right? We are in their office. I hope you are using them. If not, you should really do that. They are a really good company, really good software, and really great for communications. Yep, I have my Slack down right now. Really bad when you are doing presentations because it comes up all the time notifications, but you can silence that. I have it closed most of the time. All right, so bot. A bot is basically on Slack is, it's a code that is running somewhere and it responds to some kind of event. All right, so we will create that. Let's go with that. First of all, we will create a Google Cloud Platform account where we can actually run this. All right, so what I have already is it's set up for you. All right, this is our project. Project name is GDG Cloud Vancouver. Very original. And let's see. What Kubernetes gives you is the open API. We talked about that Kubernetes has an open API. On top of that, what Google has done is they have created Google Container Engine. So this is Google Container Engine. We should zoom in. So this is Google Container Engine. What it provides you is you don't have to worry about where are your machines and how do you update Kubernetes itself. How do you manage all the logging and everything? How do you make sure that your servers are running or not? So using Open API that is available for Kubernetes, Google has this service provided for you, which is called Google Container Engine. Kubernetes and put it on containers and you are running it on container engine. It uses Google Compute Engine in the backend. So when you are running a new machine like this right now, I have a cluster here, K8s, and it is running 1.6.4 version of Kubernetes. There's an endpoint available here. So Google manages all of this for me. There are nodes in here. There are 2 nodes. If I wanted to see which nodes are these, I can go back to Compute Engine, and we will see those nodes here. So these are the 2 nodes which are running right now. I don't have to care about this. This is the biggest thing. I don't have to worry about this, whatever these names are. Like right now, I care about this emoter booth. This is what we talked about. When there's an application, you care about that. You name it properly. You care about its health. You care about whether it is up or down. When it is a Kubernetes instance, I don't care about what it is named, where it is running, how is it running that. I don't have to worry about that. I go back to my container engine instance. And we are here. So this is Kubernetes right now. Let's follow this track. Let me close these. All right. So what we will be doing is we'll be make use of Cloud Shell. So if you are not aware, Cloud Shell is basically saying that not if, you can use it all the time. You don't want to use your machine's terminal to do things. What Google has given you is one small instance in which it is running SSH for you. You can run your code here. It's a small instance. So as soon as it boots up, I'll show that to you. It is just a virtual machine for you in the cloud. So you can do ls here. This is your machine on the cloud, which is very separate from any of the machines that are running there. You don't have to pay for it. It's just a terminal, an easy way to access all the cloud components for you. So you don't care about all of that, like connecting from your machine. How do you SSH into your cloud machines? How do you install a new SDK for Google Cloud? How do you get it all set up? You don't have to worry about that. Just click on Cloud Console. Sorry, this is Google Cloud Shell, console and shell. So shell is up there. Shell is up there for you. And what you can also do, this is a feature in beta, is you can add a code editor to that. So if we just saw that I have some folders here, where did that go? Oh, it's now here. So Cloud Shell provides you with an editor as well. So you don't have to actually worry about opening Nano or Vim and never exit out of that. So you can just use Cloud Shell and it will provide you the GUI for editing your application or editing your code. So what I have here right now is, I think there is a code which is already here, which I will delete at least. All right, it's not here actually. All right, so next step. We have a Slack team somewhere, I hope. Give me 1 sec. So this is our Slack team. If you want to create a Slack team, pretty easy process. Go to slack.com, create a new team. Simple as that. For demo purposes, we have this team right now, and there's a bot in here which I was testing earlier. All right, we'll move forward. So once you have created the Slack team, you have a Slack application running. Now for this purpose, we will do sample code. All the sample code is available on GitHub. You can look through that. You can walk through this by yourself. This whole code lab is available openly. And it takes 35 minutes, but we will do it faster, hopefully. So what I'm going to do right now is I'm going to clone. It's zoomed in. All right, it's visible. I'm going to clone this code, and then I'm going to edit the code to make sure we will see how as an application developer, I will progress through this, and I will not have to worry about application itself. I will worry about application, not how it is deployed. All right. So first step, let's clone this. No copy, come on. All right, so we go back to our Cloud Shell, run this. All right, cloning done. And we go to Cloud Slack bot. All right, that workspace is loading. While that is loading, we are here. We are in there, and we will go to the start function, start directory. So let's just see what is here. So we have our kittenbot.js file. Oh no, sorry about that. So we have a kittenbot.js file, which is the actual code that we'll be running. And since this is Node.js application, we have a package.json, which contains all the dependencies that we need to install. For this, we'll be using a botkit. So if I did, so okay, here. So this is your code editor right now. Let's see, we are in start folder. Put this down. So this is package.json. It contains one single dependency, that is botkit, that we will use to create a Slack bot. And if you want to look at the code, kittenbot, this is the code, simple code. And in few lines, you have your, what we do is we require the botkit, pretty basic Node.js application. You require your package, you build a function for that, and you run that function. So we are using botkit.slackbot to get that. Spawn. What we need here is the thing that we talked about, that you need your Slack token to actually run this up. Okay, so this will be the secret that we will save later. But let's say we are building this right now, we don't have to worry about that. We take a token and we update this. So if I go to my application, not a best practice, please don't do that. But for the demo, I'm doing this. We'll go to preferences. Oh, not here. Team settings. Nope, I'll have to look there. All right, create new app. We have a link right here. We don't have to worry about that. All right. And here, so this is Slack's application page. So on Slack, you can create your own applications. I have a few running here. With that, you can also create bot users. So what we will do is we'll create a bot user for this demo. Documentation of Slack is really good. So I hope you won't have any issues with that. Pretty clear. What you want is a bot user. So we'll go down. We will create a bot user. Add a bot user. Where is that? All right. Just said that it was really good. We have the experts. Oh, all right, my bad. Go back. Oh, I remember. That's why I had this demo gods app. So, all right, we'll create a new app. Demo day. All right, and we will choose the Slack team, GDG Vancouver. Now we have created this application inside which we will create a Slack bot. Bot users, nice. And in here we will add a bot user. So we already have a kittens one. We will add a demo day. All right. We will. So pretty basic setup. Click, click, click. You have now your bot user demo day. What we want to make sure is that I'm listening to that. Don't have to worry about that. Yep. All right. So save changes. And now I need to look at the token. All right, we go to OAuth and permissions. And we need a token from here. Oh, my bad, this is bad. All right, install apps to team. Sorry about that, I am just struggling with the small font size that I have on my screen. All right, so we have OAuth token here. What we need is, OAuth token would be, there are two types of token for Slack application. There's one for bot, one for OAuth. OAuth is basically saying that a user has to actually go through that flow of authentication, versus a bot user doesn't have to go through that authentication flow. So we'll copy this token and we will get back to the code and we will paste our token here. Please don't do that in production. And we will just start this application. So did I do npm install? Nope. So first we will install the packages that we require for running this, and then we will run this application. All of these steps are pretty clearly listed here. I am getting confused, but you should not. We have a launch code editor here. This is the code that we are looking at. We are in the application right now, and now we will run the application node kitten bot. All right. So here the application is up, it's set running, and we will see if we have our bot here. Demo day. Yep, the bot is up. You see that by this green dot here. The bot is up now. Sadly, this will still say meow because that's what the code is. So the bot is up right now. At this point, you care about this application because this is your application which is running on your machine. This cannot go from at this moment to any other platform without you doing something on top of that. So what we will do is, like we talked about an application, now we will package it using Docker into a container. All right. So we'll create a Docker container for this. So, oh, before we do that, the best practice thing, we will, rather than having this token here, we will put that token using a file which we will attach from outside. What's the file name? All right. So what I am doing is I'm removing that token from here, and I'm putting that over into the file, into the token file, and this is the new code that we will be using. It's basically changing that to look from directly into the code, and rather than doing that, it will get that from the file. So we see that here. So it requires fs. Come on. Requires fs, and then you read the file, and you get the token path, and use that to just update the code. All right, add that into the function. This is done. Now let's close this and restart this. Make sure that our application is still running after these changes. Specify Slack token path in the environment. All right. So we will use this. Now we need to pass the path. And our application is again up. This is now, rather than having our code, our token inside the code, we have moved that outside. But that file is still insecure. We will see how that you make that secure when you're running it on Kubernetes. But basically, our code right now is very different from all the secrets that are inside the code. So we are trying to follow what Kubernetes suggests. And application is up. Let's just make sure. Hello. Up. Oh, really? All right. Invalid authentication. Okay. Did I miss the file name? Oh, I copied it twice. My bad. Right. Okay. All right. Now it's up. Okay, so application is up. Changes were successful. Now we will create a Docker container out of that. So to create a Docker container, we talked about that. You just need a Docker file. So we'll use a basic Docker file. Come up here. Okay. New file. Pretty simple naming conventions. Create the Docker file. Paste it. All you need inside a Docker file is what is your base image. If you're not familiar with Docker concepts, it's basically saying that this is the operating system that I want. So for Node.js, there's an already optimized image for Node.js running on the core. There's Debian, which is running, or I think Alpine. For this is Debian. Otherwise, it will be like Alpine. And then on top of that, you have Node.js installed and then dependencies that it needs, GCC libraries and everything. And what you're saying after that is copy my package.json into this src folder, run the npm install, copy the kitten bot, and just run this command to get my application started. All right. So what we will do is right now, we will create a Docker container with that, or Docker image with that, using this Docker file. All right. Anything else we need? Yep. Okay. So what Google also provides you is, once you have built an image, you need to make sure that that image is available somewhere. All right. That image is available to your application or Kubernetes wherever it is starting up. So what you do is, this image that we will build here, we will name it based upon our project. So let's So this command here, docker build, and we are tagging this with this GCR project ID. What this will do is Google has Google container repositories. So anytime you build an image, that image can go into this container repository, which can be used now across all the Google platform, and you can use it from outside the Google platform as well. It just gives you a way of hosting those repositories or those images. My bad. All right, so this is building the image. Building Docker image, pretty basic. It pulls the library, pulls the base application. This is right now installing. This is at step 4. Then it will copy and it will start. It will just wait for that to run. All right. Hope it gets done soon. In that meantime, we will see that this is the container cluster. We will soon create a cluster here on which we will run our applications. This is right now getting into Docker container. We will first check whether this container itself is working, and then we will move this container across reliable services. That will be Kubernetes. Right. So we are running now this Docker container. Let's see if the next phase of our application where we have made it portable is working or not. So we had an application on our device, now we made it more portable. So what this gives you is this container ID, which you can see, Docker PS. So this is right now, this is the image on which it is running. This is the container ID, and it is up. So let's see. Yep, it's up. All right. So now that application is up onto our third step, which is having the container interface where you can move this across different devices or different platforms. Now we will start with our next step, which is making this more reliable. Before we do this, we need to push this image to Google Cloud GCR repositories. So we will just push this image up. We talked about Google Container Repositories. Container Repositories is where you can host your repository and it can be pulled from multiple sources. We created this image on our machine. We are now pushing it to Google Container Repository. All right. Waiting. All right. This is your code on top of Node.js repo. So Node.js image file that was there. On top of that, you are just adding this. To see this, we will go to our platform over here and go down, container registries. And here are your images. So I have few more, but this is the one that we are looking at, Slack Code Lab. This was created 4 days ago. We will see our new image that we just created should come up here really soon. So still waiting for it to get deployed. So what container registry gives you is all of your application, all of your images, as many versions as you want. I think I don't have a lot of them in this project, but in my other projects, I have like 30 or 500 different ones of them because of the daily regular updates that we do. Every time we do an update, it creates an image, pushes that to GCR, and from there it goes for the deployments. So all of those are here. You can easily search through those, easily like with these tags around here. All of these are single ones, I hope. Yeah. So Slack Code Lab, we will see the next one come up here. The best use case with this is, since this is internal to Google, you don't have to pay for it whenever it is spawning on a new machine. It uses the internal Google network to pull that through and run it on the other machine or like install it up. You have to though pay for the storage, which is pretty minimal. All right, fine, last few seconds. Get it up. This is also an important part. Like what happens sometimes is some services are slow because their container registry is slow. Those services could not fetch that image to actually start that system. And that's where the system was stuck. So you want to make sure that your container registry is fast as possible. Now we have 2 images. And this is the latest updated one. How can we know that? Based upon the tag ID 46FFA and 46FFA. This is the latest one. All right, so we just pushed it here. It's here now. Now what we will do is our application is there, our container is there, we pushed it somewhere else. Now we will start making those or running those with Kubernetes. So first of all, how do you run this on Google? For running a Kubernetes cluster on Google, you need to make use of Google Container Engine Services. So right now, this is a demo cluster that I'm running. I'm just going to create a new cluster for this, and you will see it come up here, right? And let's see if it is here. Yeah, come on. So okay, right here, it's here. So almost all of the things that you can do with Google Cloud with UI, you can also do with commands. So what I did just now is I used this command, gcloud container clusters create, to just create a cluster. I gave it 2 nodes. Okay, let me just go to Cloud Shell, better visible there. I said that I need 2 nodes. I need it in US Central region, and I need the machine types N1 standard 1. And it will just create that all for you. So you don't have to worry about installing the operating system on that machine. You just ran one command, and it will make sure that both of those machines are up, both of those machines are connected, both of those machines have public IPs available to them, and everything else that you need. What you did on your side was say, what do you need? So as a developer, you don't have to worry about which application, which machine do I run it on, how many machines do I need. For starting, you can always start on like 2 clusters. Please don't start on single machine one, because like you cannot do that, first of all, because like that fails the reliability thing. You need at least 2 to be reliable. So yeah, we did not assign it a lot of memory because this is a really small app. We will just use 10.50 GB. We have 2 CPUs running here, and this should be coming up really soon. Still creating. All right. Once it's done, what we will be able to see, okay, so what you can also see at this point is, what you did not have to do was create these machines which are getting created here right now. Come on. See these 2 new machines that are just created? Earlier we had only these 2. Now these 2 new machines were created. You don't have to worry about those. How Google spawns these machines, how Google keeps these machines up, you don't have to worry about all of that. Go back to our cluster. Takes time because they have to now install all the operating system on that. They have to make sure that they have health checks in there, so that if one of those machines goes down, they can spawn up another one. All of that is being handled by Google for you to create a cluster. That's the best and easiest way you can run a container cluster on anywhere, I guess. I'm not so familiar with other services. Azure recently came out with a good one. What you can do, just go here, select and delete, or you have similar commands with that. Yep, it just wipes the whole thing. We will do it after the event, because I don't want it to be running on my credit card and pay for that. So after the demo is done, we will delete all of this. Yeah. So it's creating. And any more questions, we can take those questions up till then while this is running. Yes. That's where the open APIs come in. I would suggest you to like go look at the open APIs that they have. Basically, what they are saying is there is a load balancer in front, and they are also pinging the load balancer all the time to make sure that load balancer is aware where the traffic is going. So first off, they tell load balancer to cut off the traffic to that pod. Then they confirm from load balancer whether the traffic is off or not, and then they do that. So think of this way, like Nginx also has an API for that. What we will be doing here is like Google-based load balancer, but Nginx also has that kind of API. All right, so this is up now. Cluster is up. See here, cluster is up. We are using 1.6.7 version, and this is our IP, public-facing IP. It gave us all the IPs. It installed Kubernetes on that. It installed operating system on that. All right, next step. Don't have to worry about that. So we talked about secrets. What we will do right now is we will use that Slack token we just had and create it as a secret so that it's not accessible to everybody. Simple commands with Kubernetes. So one of the best things about Google Cloud is it is so natively integrated with Kubernetes that as soon as you created this secret, they created this pod for you, which is a small volume that you can attach to your different VMs, all the nodes that will spawn up now. So you don't have to worry about where do you store this or how secure that is. There are conversations around this because there is, if you are not aware, HashiCorp is a really good organization around DevOps, and they have a system called Vault for securing tokens, and there are plans around attaching that to Kubernetes. But as it is right now, this is really good already. All right, we now have a secret. Now we talked about multiple levels of abstraction that you can get with Kubernetes. You can start at a node, or you can go to the services, or you can go to deployments. So what we are going to do is we'll go directly to deployments. We don't have to worry about services or nodes. We'll just go to deployment and tell Kubernetes that this is what we want up. All right. So we will create a new file here. Nice. So this is just a configuration file. We can walk through this easily. So configuration file is basically saying, so I told you that Kubernetes Open API, so you have to tell which API version you are using. So we are using extension /v1 beta. And this way, Kubernetes can take this YAML file and use that to actually keep your services up and running. This is a type of deployment. This is not a service, this is not a pod, this is not a node, this is a deployment type, and we will use that. The name, metadata name is Slack Code Lab. We want one replica of this service to be up. If it goes down, we want it to recreate that. We have added a label for this. The way we will recognize this application, this deployment, is by Slack-Code-Lab. What we need here is the image that we pushed up. So the project ID needs to be replaced. Give me 1 second. All right, so this is the link to our image. This is gcr.io, GDG Cloud Vancouver, Slack Code Lab 1. Yeah, that is there. And we created a token for this just a minutes ago with secrets. We are saying that mount that volume. So this way, what will happen is this Slack token that we created will be available here on /etc. So you can read that as a file system natively. And then we are also making the Slack token path available. Then we have a volume. Yep, and the name of the secret, that is Slack token, which we just created. So this is a configuration file. You can add more things to here. You can remove some things from here if you are not using secrets. But this is basically all you have to do in order to run on your application reliably and across platform and everything. So after this, what you do is we will use this config map that we just created, not config map, just configuration, to start your deployment. So your deployment is now created. So Kubernetes said that, okay, you asked me to create a deployment, I've created that. Now you will have to tell it to start it, right? There are ways to do that in one single command. We are just going step by step. All right, so deployment created. Now I'm telling Kubernetes is rollout. So remember we talked about how did you do rollouts? How do you upgrade one step? So we are saying Kubernetes that we just created this deployment. What I want you to do is roll this up. So this way, Kubernetes will say that, okay, are there application versions available or not? And then it will gradually roll one up, one up, one up, as many as it needs. We have asked for one, so it will just roll up to one. But we can talk about that in a, like I can change this and it will roll up more. So it's rolling up right now. So we can see how many of these are available right now. So let's see how many pods are available. We will see that it is this, yeah. So it is already ready. So normally you would see that status was coming up soon, and it is right now ready. We will see all of this. I have another demo of this, which is running all of this running, and like where you can see all of this. But this is now running on Kubernetes, and it should be up here. All right, our demo is up. Let's see. Hello. Yep. Okay. Oh, so can somebody tell me why there are two responses? Anyone who tells me that gets a t-shirt. Yes, that's the one that I was running locally. Who was that? All right, you got a t-shirt. All right, I have this running here somewhere. Or do I? That's a good question. Do I? Oh, Docker. Sorry. Even I forgot that. All right, let's stop that. and then we will have only a single instance running. That's good. Somebody want a t-shirt? All right. Anything after this? We'll clean up later, but like just wanted to show you another thing. If I set this to go up to 2, or let's say go up to 5, actually let's do a big number so that we can see it rolling up. So don't need history. Oh, that was the rolling up. So no, no worries. We'll do that in some other event. You can roll that up, scale that up to more instances, and it will run up. So finally, what we are going to do is we want to delete this. So everything is available via commands. You will first delete the application, delete the deployment, and then you can delete the container as a whole. I cannot share you the cost that I had to pay for this, but it should be less than $1. So in less than $1, you should be able to go through all of this code, run it on your site, test how Kubernetes work, learn all of this, and you can at the end delete all of this. Don't care about that. Come over here and delete that. Yeah. So even Cloud SDK is evolving every day. So there are new parameters that you need to pass, and all those documentation doesn't keep up with always the code. Yeah. And last but not the least, where is your artifact is running. So if you go to your image, people forget to do this. There are images which are still there, and you will pay for that. So go to container registry, go to your image, and delete that as well. Don't forget to do that, otherwise you will pay for that. Delete it, and done. We started with something, and we are done with that. Okay, so just to recap the whole thing. First of all, if you want an application which can run scalably and can be resilient to changes, what you want is an application which can be packaged independently. For that, you use Docker. Next, what you want is to run that application securely. For that, you need secrets, which are provided by Kubernetes. You want to make sure that your application is up and running. You need health checks for that. When you want to make sure that your application is able to run as many services as you want, and you want a high level of abstraction, you go to services or you go to deployments. All of that is done by Kubernetes for you. Best place to run Kubernetes is to run it on Google Cloud, but it's up to you. It's open source. You can run it anywhere you want. That's, I think, all is from me, and we will have Jason talk more about what do you do next. We created a very simple bot which just says meow, doesn't do a lot of things, and yeah, okay, it's already done. We already deleted everything, so it's dead. Hopefully Jason can tell you what more you can do with it and how you can make it even better. Jason. All right.
Now, in theory, just plugging this in should work. Let's see. Cool, it worked. All right, hello. Oh, that's loud. All right, so I have a clicker. I forgot I had a clicker. Cool, it works. All right, so I'm Jason Roche. I'm on Slack's developer relations team. My team builds SDKs, maintains SDKs, writes documentation, tutorials, examples, coordinates meetups like this one. And we field a lot of questions in the development community. So if you ask a question on Dev for Slack or email, it's likely to come to us or our awesome developer CE team. So what I'm going to cover today, the clicker is no longer working. All right, I will manually click. All right, so how many of you use Slack? Awesome. How many of you have built a Slack app? Oh, a few. Awesome. Nice. So if you use Slack, or if you've seen any of the ad campaigns, Slack's mission is to make people's working lives simpler, more pleasant, and more productive. Slack developer relations mission is to make people's working lives simpler, more productive, and more enjoyable by providing developers with the best tools, documentation, and support to build apps which are useful, powerful, and enjoyable. So you may wonder, what does useful mean in the context of work? Being put to use, valuable or productive. So expanding upon somebody's work to make them more productive. What is productivity? Achieving something or working hard and getting results. So how do Slack apps make people more productive? How many of you use Slack apps in your Slack teams? A few, okay. Probably mostly Giphy. Giphy is great. So one of the most common Slack app types is notifications. That can be anything from, we use, if you saw the iPad on the counter when you came in, we use an app called Envoy. Envoy allows guests to check in, and then it lets them specify who they're here to visit, and it sends a message to the person they're visiting to let them know, hey, this person's here, go meet them. The workflow there is pretty simple. It's getting up, going to meet a person. Once you've done that, the work is generally done. So other notifications, more passive. You may have an RSS reader that pipes RSS feeds into your channel. It's more of a passive notification. You just see it when you see it. You click the link whenever you want. Then you have things like a GitHub pull request notification. Here, there's work to be done. You have to go review the pull request. You click out into the app or into GitHub, and then you do the workflow off outside of Slack. So those are a few types of the most common notifications. So they should be timely and informative. You know, the RSS reader posts as soon as a blog post is posted. It doesn't post days later. The GitHub pull request notification tool tells you right away there's work to be done. If it's, you know, a critical patch, you know the work is there and it needs to be done. With Envoy, it tells you immediately that your person's here and that you don't want to leave them there for 2 hours. I mean, you could, but you probably shouldn't. It should be relevant to the audience you're posting it to. So if you have an engineering team or a sales team, maybe you don't want to post the sales reports to everybody. Maybe you don't want to post the sales reports to the facilities team or, you know, whoever may not be as interested. Again, they should be thoughtfully scoped. So if you have a message that's specific to one person, like in the case of Envoy, posting that to a public channel is probably not the best scope for that. Maybe a DM, or we just released ephemeral messages today that would be pretty good for this, or even in a thread. So those notifications, anytime you receive a message, it invokes some sort of feeling. With the GitHub notification, there's a lot of content there, but that content is relevant. Maybe you don't need all that. With Envoy and the Python RSS reader, it's concise. It's nicely packaged, a good summary. Just keep it consumable. It should be engaging. You can attach photos, you can attach buttons and all kinds of interactive things. It allows you to get the user's attention in a way that drives them to either do the workflow or go out and see the rest of that content. Again, with the rich content, a lot of people use the image. There's a really cool app, StatsBot. What they do is when they're loading your stats report, they attach an animated GIF that has like an animation of their logo loading, which is super neat. And then once your report loads, it swaps out that content. So it just kind of, it gives the user something, it lets them know some work is being done. It just doesn't sit there and stagnate. So to elaborate a little bit on the GitHub example, this is my fake shipping app, which is kind of ideally sort of a GitHub clone. So somebody submits a patch, you have a link out to do that review and merge that code. So you, as the user in Slack, the bot posts the message to you, and then you have to go out and manually do that workflow. So with the message menus and message buttons that we released a while back, oh, my slides are out of order, okay. So how do we make that notification more useful? It should be actionable. Right now, the only action you can take is clicking the link, going out to another site, and doing work there. It should feel intuitive. If you add calls to action, or if you add a link, or if you add buttons, it should be clear to the user what those buttons do. And it should provide a path to get work done. It should go directly to the resource that they need, or it should do the work right there in the channel. So here's a couple examples of interactive workflows using message menus and message buttons. On the left here, we have kind of an HR app, which allows you to approve an applicant or approve their hiring offer right here in the message. So the entire team, the entire HR team will see that, or the entire recruiting team will see that. As soon as they click on that button, it updates the status of that message to say that it's been done. So you don't have a duplication of work. And then on the right, you have a kind of a project management tool, which allows you to specify when a task needs to be done. And rather than, the bot messaging you, hey, when would you like to do this? And you responding tomorrow, and it having to do some NPL and LP, I always mix those two up. Rather than having to farm that out to another service, just give the user a dropdown of some options. Sometimes it's simpler than a conversational UI. So elaborating a little bit more on the hiring tool, you can see here, as soon as the work is done, it reflects who made that change and that it's already done. So if somebody's out to lunch, they come back, they hop into the channel, they can see, oh, this came up, it's already handled. Or if it hasn't, the button will still be there and they know that there's work to be done. Here's another example with nested message buttons. So it's a multi-tiered workflow. And rather than just exposing everything in a sea of buttons, this actually guides the user through the workflow in kind of a wizard method. So here's revisiting the fake GitHub example. Here's how that workflow goes with an app that can actually take action. So the bot posts to the channel. The user takes action right there in the message, in the channel. The bot goes out, hits GitHub's API, and makes the change for them. So they don't have to leave the channel. It's very clear to other people on the team that the work has been done. There's a timestamp. Just everything is handled right there. You don't have to context switch out, log in, do all those things. And then same thing using message menus. So one of the options for message menus is to actually pull in a list of all the members on the team. So if you need to assign that task to somebody, you can just pull in that list right there with one param on the message attachment, and it automatically populates that. You don't need to fetch all the users manually, populate the list, and then serve it. It loads it right there for you. So you can actually assign a task, and then once you assign it, you'll update the message and show, oh, this task was assigned by this person to this person. So again, it relieves a little bit of the wondering what the state of a task is and shows who's responsible for it. So here's an example that my team at Anchor made. This is a coffee ordering bot, which is actually on GitHub. It's a Node app. You could deploy it to Kubernetes. And you can see it updates the status of the message right there to show you which steps have been completed and where you're at in the flow, and it builds the order and then submits it. So as you can see with that coffee ordering app, it's doing a few different things. One of the things it's doing is it's kind of cleaning up after itself. So if you have a notification or a workflow tool, and it's just posting a new message for each state change, that's going to get pretty noisy pretty fast. If you have a deploy tool, that might be fine. But if it's a workflow thing like that coffee ordering example, that could, if you have 10 people using that in a channel, it could get real noisy real fast. You can add content dynamically, like the StatsBot example I mentioned. When you click to load a task or load a report, it automatically swaps the buttons with that loading image and then replaces that with a link out to the report. So instead of posting all of these things, it just updates right there on the fly. And then removing unneeded content. An example of that would be the Salesforce app. So rather than showing all these messages to the entire channel, you can see, it's a little fast, but you can see the only visible to you tag on there. That means it's an ephemeral message. The person who clicked on that button is the only person that can see it. So rather than showing the entire workflow to the entire channel, this allows the user to compile all of the stats they want to show to the rest of the team, kind of in their own interaction. And then once they're done, it posts out to the rest of the team. So you can see right here, select some details, post this one to the channel. All of this is specific to the user, and then it only posts that to the rest of the team. So it kind of cleans it up a little bit. And then here's an example of progressively adding info. Poly did this really cool thing where they used the message attachments as a mechanism to hide and show comments by just replacing the state of the attachments on the message. So the attachments are just a JSON blob that you pass in along with the message, either with a chat post message or chat update. And you can dynamically swap out those attachments in real time. So it gives it this really cool effect of being able to kind of collapse it down. Here's another great example of the visual cues and sort of showing the status of a task. Attachments allow you to specify the border color, and you can utilize that to show the state of a task. It's a immediate visual cue for what work needs to be done. So Ops Genie is a DevOps tool. Let's say you come back from lunch, you see this red border, you think, oh, this work needs to be done. Once you select an action to take, it goes through and changes that border color. So someone else coming back into the channel knows immediately the state of this task. It's already done. It gives you a log of the action that was taken, who took it. And then this is an app that we just open sourced last week, actually, as part of a new API beta program. But we use this internally at Slack all the time. Anytime you want to go get coffee or you want to go to a specific restaurant, you start a lunch train and other people can kind of hop onto it. So instead of messaging everybody, hey, do you want to go to this place for lunch? Hey, do you want to go to this place for lunch? You can just post that in the channel and everybody can hop on. So one of the cool things this does, you can see it takes advantage of the ephemeral messages up there. So that top one is only shown to you. And then down here, it starts with just board this train. And as soon as somebody joins it, it appends their name to that list. So instead of posting a bunch of different status messages, it updates right there in line. And then so this is leaving at 4:45. As soon as 4:45 hits, it sends a notification to the people who opted in, and then it updates the original message in the channel, removes the button, shows the past tense message, oh, the train left, these people left. So it's kind of a good example of how to clean up after yourself and tidy up the conversation. So this is a little long. I'll post a link to the slides later, but it's just basically your app should provide users with information that's timely, concise, and actionable. Tell them exactly what work needs to be done and give them a path to get it done. And it should clean up after itself to tidy up the channel. And if you do all those things, your app will just be easy to use and extremely powerful. So it's just, take that basic notification app and just expand it out little by little, and you can have an amazing app that allows somebody to get so much more work done right there without leaving the context that everyone else can see. So we have a platform news app, which you can, if you're a developer developing on the Slack platform, any feature releases, API changes, event announcements, things like that, will automatically get posted into the channel that you specify. We're on Twitter, of course, Slack API, and then our docs are api.slack.com, and if you haven't read them, they're amazing. They have a lot of thinly veiled Ghostbusters references and things in them. They're pretty great. Taylor, the guy who writes them, he's ridiculous. He's awesome. Our platform roadmap is on Trello. It's public. You can see the things that we're shipping this week. You can see the things we're shipping next quarter. The things that are kind of down the road that we want to do. You can provide us with your feedback. If there's a thing that you want, you can let us know at any of those resources. Let's build great things together. And there's also an event coming up in San Francisco. And there's a discount code on here. So if you want to take a picture, if you're interested in this, use that discount code. And we'd love to see you. Questions? There's a failback attribute in the message. So that situation, not that I know of. I don't think so. No, because it's dependent on what is at the end of the connection. So like in an events API scenario, we don't really have much visibility over what's consuming it. All we know is the status code that it gave us. Yes. A bot is, so there can be. A bot, in my mind, is an app that has a bot user. So if you have an app that's just doing things behind the scenes and not necessarily interacting with the users, then yeah, you could have an app without a bot. A bot user is not required, but it gives you the mechanism that the app will use to communicate with the user. And apps, I don't know if anyone has seen in your team at the bottom left below users, there's a little apps section, so you can see the things that are installed. It's pretty cool. Any more questions? Yes. Well, the events API helps a little bit with that. But I don't think we have anything specific planned right now. But events API is the newest dispatch mechanism that we have, and it makes scaling much simpler than RTM. So the example that they put together is on BotKit. BotKit gives you the option of using either RTM or the events API. They had some apps built on that were using or connecting to like 10,000 teams or 10,000 users. For every user that it was connecting, it spins up a WebSocket. So if you want to scale that on, either Google's cloud architecture or AWS, you have a ton of outgoing connections. And that makes scalability and also kind of a load balancing situation much more difficult. And as you saw with this example, if you have multiple instances running with the same keys, each one is actioning on that. So Events API just gives you one incoming endpoint, and then you can either put that behind a load balancer and round robin there, and it allows you to dedupe on some extra parameters that are attached to the message, if that makes sense. Anything else? Questions, comments, jokes? No? All right. Cool. Yeah, you should come to Frontiers. I don't know if any of you are traveling to SF or do travel to SF, but it'll be a lot of fun. It's for developers, it's for customers. There will be swag, of course. So, yeah. Cool. Thanks for coming in.